Hi guys, welcome to God Academy. In this lesson, I'll be taking you through the type 2 of mathematical induction, which is under divisibility. I have a problem here. It says, prove that a to the power n minus 1 is divisible by 7 for all n which are a member of natural numbers. Let's get straight to this problem. In our previous lessons, we solved the type 1 and we solved a couple of examples. So in this lesson, we continue solving the type 2. So how do we solve this? As usual, number 1, our base case, okay? So our base case, we have um, our statement. So first of all, let P of n be equal to the statement, which is a to the power n minus 1, okay? So to test for our base case, P of 1, we're going to have a to the power 1 minus 1, and that is equal to 7. 7 is divisible by 7, so it's true, perfectly true, right? So our base case is tested, so therefore base case is true. Now number 2 is induction hypothesis, right? Induction hypothesis. For our induction hypothesis, we assume that our statements P of k is true for n is equal to k, okay? So for n is equal to k, we assume that our statement will be true. So P of k is true. Therefore, our statement now becomes P of k, which is mapping to a to the power k minus 1. So the assumption is saying that let's assume that a to the power k minus 1 is divisible by what? 7. That is all. Then we move to our induction step. So for the induction step, it quickly says that we have to prove that our statement P of n is true for n equals k plus 1. So proving for n equals k plus 1, we are going to use the assumption very much. But now let's see something. If we are assuming that this expression is divisible by 7, how do we quantitatively express this? Because you cannot tell me that a to the power k minus 1, let's assume is divisible by 7. So I can only assume when I equate this to a certain term, that term should be exactly divisible by 7. So I'll choose 7 times any unknown, right? Let's say if I use m, n is going to be confusing, right? So let's say 7 times p, okay? So let's assume that a to the power k minus 1 is equal to 7p, because 7p is divisible by what? 7, right? Because 7 will cancel in the with p. P is just an unknown to show that indeed our expression here is divisible by 7. So the assumption holds. Now in the induction step, we are going to say that P of k plus 1, which is mapping to a to the power k plus 1 minus 1, should be divisible by 7. But how do I prove that this expression a to the power k plus 1 should be divisible by 7? I can only do that by making use of the assumption. Now let's just simplify this. If I have 8 to the power k plus 1 minus 1, this expression is the same as 8 multiplying a to the power k minus 1. Right. So let's see something here. You realize that when you have the expression we have here, right? The expression we have here is simple. So I'm going to have from my assumption, the assumption says that a to the power k minus 1 is what? Equal to 7p, indicating that it's divisible by 7. So how do I apply that here? How do I apply that here? So in applying that here, you know that we have a to the power k plus 1, but indices we decompose, we get 8 multiplying a to the power what? K, right? Okay, so at this point, what do we do? At this point, it's so simple. We can make a to the power k the subject from our assumption. So from our assumption, we can say that 8 to the power k minus 1, which is equal to 7p, making 8 to the power k the subject. I'll have 8 to the power k is equal to 7p plus 1, right? I'll come and put it inside my inductive step. So I'll simply have 8 multiplying 7p plus 1 minus 1. And what am I seeing here? I'll have 8 multiplied by 7p, then, sorry, let me clean this. I'll simply have 8756p, 818, right? Then minus 1. This gives me 56p plus 7. Is this expression divisible by 7? Yes, it's divisible by 7, right? Because 7 goes into 56, 8. 7 goes into itself, 7. So when you add, you're surely going to get that. And that is how we prove for divisibility mathematical induction. And that is all for this video. See you in the next video. Bye.